Hello all, so we're live once again, and today we're going to talk about functions. First of all, let me start the webcam. Yeah, should be good. Yeah, here we go. So today we're going to talk about functions and also lambda functions. And so let's just start with it because it's going to be a little bit long, probably. We have already talked about functions in the past, so this will be mostly a recap. So Kotlin functions are declared using the fun keyword, and for example, you can define the function that gives the double of a certain x integer value in this way. So, for example, you can have test, test, double, and then you give an integer like 2, and then we create this function, and we say return I times 2, and then we have to return this, and we return it as integer in this case, and this will give us the double of the number that we're giving, and this is basically a way of printing it. So double of I, if you define I in a value or a variable, it can be something like this, and we just run it to see our result. So do we have our results? Yes, 2 and 4. Calling member function uses dot annotation. So yeah, for example, if you have a class which is stream and want to call the read function, you just do dot read. Then you have parameters which are defined using Pascal notation, which means name and type. So the Pascal notation is name, columns, and type. And parameters are separated using commas, and each parameter must be explicitly typed. So you cannot have a parameter that doesn't have a type, like no type here, because it will raise an error. It will say I need a type is required. You can use a trailing comma when you declare function parameters. So you can have also like two parameters. Let's call this multiply, and let's do something like this: integer equals b. So when you do multiply, you can separate them by comma, or you can also put them in multiple lines, still with the comma. It's not allowed not to have the comma. And this might be useful if you have long parameter names or a lot of parameters, and that might not be readable anymore. Because maybe you get here with your list of parameters and then you cannot read them anymore. If you place them in multiple lines, then you can read them properly. So function parameters can have default values, which are used when you skip the corresponding argument, and this reduces the number of overloads. So for example, you can have multiply 2 by 3 as default, and you can multiply I by I. Doesn't make any sense. So multiply we said 2 and 3, and we say multiply without specifying the parameters because we're using the default ones, and this should be as the result, which is 6. You can see. Okay, so a default value, yeah, is set by appending an equal, as we have seen. Overriding method always use the base method's default parameter values. When overriding a method that has default parameter values, the default parameter values must be omitted from signature. So if you want to override and use the default parameters, you can do so. And no default parameters is allowed on overriding functions. So you can only use 10. So let's make this example very quickly. Point test. Yeah, test class. .kt. Then we have A and B. And what we want to do is create B and pass in something. So let's do line I. And over here, we just call print line I. So yeah, no default is allowed here. So let's now create an instance of B. Instance of B, and we call foo. Then we call foo. Import that from our example, and then we call foo. This should output n because it takes the default parameter from the overridden class. So let's see if it does so. Yeah, wait. Yeah, it did. Yeah, I'm printing. This doesn't make sense to print the instance. We just directly run it like this. So we have our 10. Full output is 10. And the function which is running is this one. The default parameter is passed by foo. So you see here, this was the original implementation, and this is the overridden implementation. What I could do is I could call also the super, probably. No, maybe I have to pass it like this. Or this creates recursion. There should be a way to call the super function, but we'll see it if there is any mention of it in the docs. So if a default parameter precedes a parameter with no default value, the default value can only be used by calling the function with named arguments. So yeah. Yeah, here they used similar names. So buds is the second parameter, and for the first parameter, the default, which is bar, is used. So let's make an example here. We create another foo, and we say bar in is 0 and coffee in like this. So when you want to call this function, another foo, So let's do it like this. B is this, and then you say B dot full, and then let's call B dot yeah. Let's do another tool. And yeah, as you see, you need to specify all the remaining arguments because it needs copy to be specified. That's what I wanted to show. And whereas if you like reverse this, so let's say you have copy and then you have something else like int which is equals to 3, copy. Okay, here you need to do another full tool. And now what I want to show you is that you could call this without the name argument because it's the first argument that you are changing. So basically, as you see here, it's if you specify it as a first argument, the optional argument is the first one, then you can skip typing the second argument or the name of the argument. And if it's the first one, if the first one has specified a certain default value and the second one has not, then you need to specify the name of the argument. Otherwise, it won't work. Okay, so if the last argument after default after default parameters is a lambda, you can pass it either as a named argument or outside the parentheses. So this is something cool. For example, if you have a lambda which is a specific function that takes some arguments and returns a certain type, like in this case, you could specify it both inside parameters at the end after calling the function with its arguments, and then you could also use the named parameter and then pass the lambda, or you could just use the default values if there are default values, of course. So in our case, that would look like therefore that will look like run after print. It would look like this. Run after print. Yeah, you have to call it. And then here you can specify the print line. Run after print. And then you can do the same with by specifying like all named arguments after print, and you copy these, you remove the parentheses because you have already specified them, and it will behave the same. Okay, you see here. All right, let's go on with named arguments. So you can name one or more you can name one or more of a function's argument when calling it. This can be useful when a function has many arguments and it's difficult to associate a value with an argument, especially if it's a Boolean or null value. When you use a named argument in a function call, you can freely change the order that they are listed in. If you want to use their default values, you can just leave these arguments out altogether. Consider the reformat function, which has 4 arguments with default values. So when calling this function, you don't have to name all its arguments. You can just, for example, name the first one. Avoid naming the first and the second, but you can specify the third and the fourth. But I wouldn't recommend doing this because suppose that, for example, you are using a function like this, which reformats the string, but you're not passing the name of the argument here. And then this field, for some reason, is specified as this field. So if you imagine you don't specify this, you don't specify the name of this, so this is not here. If what happens if uppercase and normalized case for some reason in the API gets switched, then you might be setting the wrong parameter, like wrong Boolean value, to the field that you don't want to set. So, for example, I will explain this. Fun, don't mess up. Like you have uppercase Boolean, and here you have separator, like you add suffix. Okay, so imagine that, and then you have suffix, which is like suffix. So like, don't mess up with names. We take the string that we're passing in as here. Sorry, into the string, and we say s dot apply if s is if uppercase, then this dot uppercase, and then what we do is this: if add suffix, then this dot plus suffix. All right. So we have uppercase and then suffix. We call this function right here, and we say hello. Then we say we want it as uppercase, and we want this to be false, so no suffix is added. And let's run this. Run. All right, don't mess up with names. So what gets printed out here is hello. We have done something wrong here. Why is it not returned? Let me check. Yeah, we should use let return the value. Let me check again. Run. Let's do like this. Okay. Nope. Not going in uppercase yet. Uh, so let's do it the old school way. In our case, we just want to print. Let's run this. Okay, now we have our uppercase result. And suppose that uppercase and add suffix get switched for some reason in this API, then you don't get any issue when you compile, but the behavior has changed. So you were thinking that you were adding uppercase, and for some reason now you're adding a suffix. So if this wouldn't have happened if you had added named arguments to all of your parameters. For example, if you say this was false and this was true, and you switch back here, there's no issue anymore because you are specifying the parameter. And so you get the uppercase as you wanted. And here you can switch back like before and you're good again, because now you're specifying the name. So that's pretty much it. You can avoid specifying some parameters, but again, this is not suggested. So like here and here, you could do this, but again, it might lead to issues as we said before. You can pass a variable number of arguments with the var arg with names using the spread operator. So for example, you can pass an array of ABC to the foo function. So let's try and do this. Let's call these separated strings var arg with type string. And now we go here and we say also separator string. String, and our separator is going to be underscore. And yeah, here it should be like this. And we want to say for yeah, separated strings for each it plus separator, and then yeah, we say val new separated is equal to this, and you say separated string. Yeah, here we want to append it separated, new separated, add. Oh, this should be plus equal to the variable, and then we print line the newly separated string. Let's run this. So of course we haven't passed anything, but if we do, so separated strings equals to array of, and then we say A, B, they will be separated by our dash, and we can remove suffix what? Oh, okay. Very good. So when calling Java functions in the JVM, you can't use the named argument syntax because Java bytecode does not allow pres to always does not always preserve the name of function parameters. Okay. Next, unit returning functions. If a function does not return a useful value, its return type is unit. Unit is a type with only one value, unit, and this value does not have to be returned explicitly. So yeah, these are like this function we've made is a unit function which does not return anything. The unit return type declaration is also optional. The above code is equivalent to print hello name string, right? Single expression functions. So you could create a single expression functions. So when the function body consists of a single expression, the curly braces can be omitted, and the body specified after an equal symbol. So, for example, we could simplify our. So it was not here probably. It was double multiply. So let's move them over here. And let's do fun double I int, and we call it shorter. And this basically, it does the same thing, but it's more compact. So now let's create this B over here. And let's do B dots, B dots. Okay, so you can use either double or double shorter to call this function, and it will behave the same. Perfect. The return type is optional as it can be inferred from the expression in this case. So shorter no return optional, if this is also possible, and you can see it's inferred, and the compiler will know the type that is returned by this function. Perfect. Explicit return types. So functions with block body must always be specified when must always specify return types explicitly unless it's intended for them to return unit, in which case specifying the return type is optional. So Kotlin does not infer the return type for functions with block bodies because such functions may have complex control flow in the body and the return type will not be obvious to the reader. So in what happens is that in these cases, when you have more expressions inside a function and you're not using this type of syntax, which single expression function. So let's call it a double in single expression. When you have a single expression function, the return type is easy to determine, and in these cases, it's not. Not easy. All right, explicit return types, variable number of arguments. You can mark a parameter of a function with var arg modifier, usually the last one. In this case, you can pass a variable number of arguments to the function. So I think we're declaring yeah, if you, for example, declare this as I don't think you can like say A, B, C. So the separator is going to be separator. Yeah, maybe you can do what I'm doing now. So instead of passing them as a specific array, you could pass in the arguments like this, and it will work anyway. So if var, the parameter is not the last one, in the list, values for the subsequent parameters must be passed using the named argument syntax. So yeah, if you don't do this, you must specify the parameters with named argument syntax. Or if the parameter is a function type, by passing a lambda outside the parentheses. Okay. When you call a var function, you can pass arguments individually. For example, as list 1, 2, 3, 4. If you already have an array and want to pass its contents to the function, use the spread operator. So yeah, if you have like an array, you can pass the array like val more data like array of de, and if you use the spread operator, which is this type of operator, and you see more data, then this works as it will split the parameters and pass them to the var arg, and this might be useful in some cases. So if you want to pass a primitive array like int array of, I don't know if you remember, but we saw there was a difference in primitive arrays versus non-primitive arrays, like let's do this very quickly. Let's call ChatGPT difference between arrays and non-primitive arrays in Kotlin. So yeah, when used with primitives, the values are boxed, which can lead to performance overhead, whereas primitive arrays, they're more efficient because they store values directly and they're unboxed. So what I would suggest, yeah, following this, if you have a boxed array, so yeah, if you have sorry, an unboxed array, which is more efficient, like integer array here. Let's do this. Unboxed data, and we call it int array of. Sorry. So we have it here, 1, 2, 3. You can pass this unboxed data, but you need to convert it to a typed array. Probably you also need parentheses here. To typed array. Let's see what issue we have. Typed and matched. Okay, because it needs a string. Sorry, that's my fault. So 1, 2, 3, but we need to say, okay, do we have the string array of? Probably not. In the primitives, we have char array. So char, so we can use char array, char probably, and we need to specify them as char. Okay, good. All right, it wants them as string. So let's try and do this. String. Yeah, it's a bit hard to fix this example because it wants strings. array of strings. So now it's a typed array of characters. And what if I want to change convert yeah, since I'm not okay, this dot to string that should make what we want. So we're using a map in order to map the result into strings per typed. So we need to do typed array again. All right. So we first map it to string, and then we convert it to typed array. Let's try it and run it. So yeah, it's possible. From starting from a char array, we first map it to a string, and then we convert it to a typed array. It's okay. Then we see the infix notation. Functions marked with the infix keyword can also be called using the infix notation. Infix functions must meet the following requirements. They must be member functions or extension functions. And they must have a single parameter, not more than one. And the parameter must accept a variable number of arguments and must have no default value. So, for example, SHL, yeah, SHL, what is that? Let's create an infix function, but for something like double like triples. So this should be marked with the infix, and then we should have the return type. Right? The return type, then we should have the input parameter, and then we should have the return types. So yeah, integer dot triple return type, and then we have return I times 3, and this is now usable by going so it's interesting. I think this should be outside of the function. Sorry, of the class, because we want to do 3 triple. All right, not triple, but multiply, because what we want to do is this times I. Okay, so the this type is integer, and the I type, which is the second argument passed, is also integer. And okay, create extension function triple. Yeah, we have called it multiply. Now we can import it and we can print the result. 3 times 5 should be 15. Okay, I will reference triple. Let's delete this, run again. Okay, we have 15, perfect. So well, the advantage of this is that they can be called using the infix notation. So omitting the dot and parentheses for the code. You cannot have the two parameters, but only a single one. And the members, they must be member functions or extension functions. So this is an extension functions of integer. Member functions and you could also do as we were doing before, so you could declare it inside a class, so that's what a member function means, or also inside an object. So let's try and do something like, yeah, let's make it like b as past a value like past, and this is private val. And you could do it also in this way. So when we create b now, we pass value. So for example, our value is now 6, and we do b dot multiply 6. So, sorry, 6 and 3. So it should be equal to 18. 6 times 3 equals 18. But yeah, I forgot to use the infix notation. And how do you use it now? That's the question. Yeah, you need to use it inside the class. So it doesn't make sense to use it here, but you can use the function anyway. Like fun brings multiply with infix, and now let's do PoliMi. Past multiply I. Like x, and now we can call b dot string multiply with infix 3, and it should do the same. Yeah, basically shouldn't be printed. Perfect. So you have print multiply with infix. You are using infix inside the class directly, as they're doing here. Function scope. So Kotlin functions can be declared at the top level in a file, meaning you do not need to create a class to hold a function, which you are required to do in languages such as Java, C#, and Scala. So as we have done here, we have declared a function in the top level file. In addition to top level functions, Kotlin functions can also be declared locally as member functions and extension functions. So you can declare a function inside a function, and you may also have, this is an extension function, and it's declared inside the file scope. As you can see here, what you could do is declare a function like print that stuff and call it and here maybe you say big I equals I plus 10, and then you say print that stuff I. You can do that. A local function that can access local variables or other functions, the closure. In that case, above visited can be a local variable. So you might directly reference the modded I over here. And instead of passing it here, you can pass it directly as a variable, but I think that this is outside of the scope for the function. Like if you do plus equal 1, it will say a result reference. So this is not allowed, of course. Not seen in the full. Okay, then you have member functions, which are members of a class or an object, as we said before. And they're called with dot notation. Then you have generic functions. And generic functions allow you to define a generic type. And they're specified using angled brackets before the function name. So for example, you have a function which will return as a list given a certain item t. And this can be generic, so it can be used with strings and integers at the same time. So let's try and create this singleton list, and then we say we must pass an item of type t, and we will return a list of type t. And this function, what it will do, it will just list of item. So this is a bit of a trick because in our case there is a generic function for list of, so we're using that as an advantage. And anyway, with this syntax, we just replicate what they're doing here, and we can use singleton list. Singleton list 4, and this should print a singleton list with one element, basically. And the advantage here is that it can work with things like strings as well. So that's the useful part. Tailed recursive functions. So let's see what this is. Kotlin supports a style of functional programming known as tailed recursion. For some algorithms that would normally use loops, you can use a recursive function instead without the risk of stack overflow. So when a function is marked with tailed rec modifier meets the required formal conditions, the compiler optimizes out the recursion, leaving behind a function-efficient loop-based version instead. So yeah, it basically converts from a recursive function to its non-recursive function, which is optimized for calculation and is more efficient to and meets the required formal conditions. So it should meet, of course, some conditions known by the compiler. This code calculates the fixed point of cosine, which is a mathematical constant. It simply calls, math.cos. So this is more advanced for when you need to do some calculations. But basically what they're saying is that it will convert this type of code, which is, well, easily written with recursion, to its non-recursive function, which is this one, which might be harder for you to code if you think it in a non-recursive way. So yeah, non-recursive functions are usually harder to think them of, and this is why they have created this tailrec modifier. All right, so let's see how much time we've got. I think we should do lambdas in tomorrow's lesson. I will make a lesson also tomorrow in order to talk about lambdas, because otherwise we will not finish in time the course. So thank you guys for watching, and I hope to see you on the next one tomorrow. Thank you. Bye bye.